Okay, hello everyone. So I'll be presenting the Predicting Media Memorability task. This is our second year running this task, and I'll go through a presentation of the test descriptions, of some annotation protocols, and you will also see the team's results and some, let's say, common conclusions, some conclusions, some observations, and some general trends that some of the teams saw during this task. So the scope of the task is to create some systems that can predict memorability scores for videos. Basically, these memorability scores represent the probability that a certain video sample will be remembered after a certain period of time by people who watch the video sample. Here we used some short, meaning 7-second videos. They were soundless. Basically what we wanted here is to get a visual interpretation of memorability. Basically in the literature, this is perceived as an intrinsic attribute of images and videos. There are several papers which analyze this, and the conclusions were that certain images or certain videos are intrinsically more memorable than others. So this would basically create a testing ground for our task. Here we split the task into two subtasks, analyzing the short-term memorability, which wanted to see if the participants to the recognition tests can remember that they saw the video after a few minutes or after a few hours, and long-time memorability, which went on for longer after 24 to 72 hours, the same recognition task. Basically, we've got multiple use cases here. So memorability can be used, of course, in advertising, in education, for making sure that what we show our students will be remembered or has a better chance of being remembered. And it can also be used for creating video summaries, making sure that the summary of longer videos is memorable. And it can also be used in medicine, in basically testing how certain patients, how good certain patients' memory is by comparing it with, let's say, a baseline that is taken from the general population. So, furthermore, this is the annotation process. We had two separate steps, one for the short-term memorability and another one for the long-term. Basically, the participants saw a bunch of videos, and for the short-term memorability, we had a target repeat after 45 to 100 videos. So after 45 to 100 videos, the video was shown again to the participants. They had to say, okay, I recognize this video, I've seen it before, I've memorized it. We also had some vigilance repeats. We wanted to know if how good the annotation process is, so we used those vigilance repeats to make sure that the participants were paying attention. The next step was the long-term recognition task. This came after 24 to 72 hours. So basically it was the same repeating of previously seen videos, only this happened much later. This way we could measure both short-term and long-term memorability for the same set of initial videos. Finally, we came up with a data set composed of 10,000 videos, split into 8,000 for the dev set and 2,000 for the test set. We also provided the number of annotators for each individual video, for each individual subtask in the ground truth data. A couple of pre-computed features. So we have some traditional image features, including color histogram, HOG, LBP, ORB, and aesthetic features, and some classic video features, extracting histogram of motion patterns. And we also pre-provided some deep image features with the Inception v3 layer, and some deep video features using the C3D. Also, we provided some video titles that could actually be used as captions, as textual features. These video titles represent actually a high level representation of what is going on in the video. So evaluation was carried out using Spearman's rank correlation. And I'm going to show you some examples. Okay, so the first video has high scores both in terms of short-term and in terms of long-term memorability. And the second one has low scores. Basically, I picked these two videos. They are either at the top or at the bottom. So they have actually they have very high scores or very low scores. We had 8 teams sending in their runs. All of them participated both at the short-term and at the long-term task. Most of them submitted 5 runs for each subtask, which was the default requirement, but teams were also allowed to send less runs. As you can see, the results are quite close. I will show you a short comparison with some other results. So basically, the best 2 results, 0.528 for short term and 0.277 for long term, surpassed the best results from last year, which you can see here. Furthermore, we took a baseline computed with MemNet, so it was an image-based baseline. And again, every result was above this baseline. Furthermore, every result this year was above the average from last year. So we definitely saw results improved, and this is a very good thing. Now, some general trends. As you saw, and as it was also the case last year, short-term memorability had better results than long-term. Also, the results were improved when compared with last year's, as I was saying. Now, regarding the team's runs, what we saw was the tendency for weighted ensembles to provide better results. Also, regarding the ensemble models, generally the ones with different modalities had better results than ensembles over the same modality. Finally, many teams use the caption data, the movie titles I was telling you about, and this also improved their results. Also, deep components, so either meaning deep learning used to classify the movies, or deep features extracted from deep neural networks, improve the results. Some participants presented an interesting analysis relating certain concepts with memorability. So let's say they were able to analyze whether movies containing people are more interesting, are more memorable, than movies containing nature. And this was a very interesting analysis for me. And finally, some other teams performed PCA or other types of feature dimensionality reduction, and this also improved the results. So, thank you.